Welcome to Summarize Science. Today, we are looking at a breakthrough in 3D reconstruction from internet photos. Most of us take photos of landmarks, but only a tiny fraction of places are famous enough to have thousands of pictures online. These famous spots, like the Colosseum, are easy for computers to turn into 3D models because the data is so dense. However, the researchers explain that the vast majority of real-world sites are part of what they call the long-tail distribution. These are places with only a few, noisy, or sparse images, making 3D reconstruction incredibly difficult for standard software. Current AI models often struggle with these obscure locations, resulting in fragmented or incorrect 3D shapes. To solve this, the researchers introduced a massive new dataset called MegaDepth-X. This dataset is much larger and cleaner than previous versions, providing a better foundation for training AI. One of the biggest hurdles they addressed is the doppelganger problem, where two different sides of a building look identical. By using advanced filtering, the researchers created a ground truth dataset that avoids these confusing errors. The team also dealt with artifacts like depth bleeding and transient objects, such as people walking in front of a camera. They used monocular depth predictions to clean up the images, effectively removing moving parts that shouldn't be in a 3D model. This ensures the final reconstruction remains focused on the actual, static architecture. They also developed a clever strategy to simulate sparse photo collections using well-photographed sites. This process, called sparsity-aware sampling, trains the AI to understand a scene even when key perspectives are missing. The team used graph theory to identify distinct viewing areas and select a diverse set of images to challenge the model during training. The results are impressive, especially for scenes where traditional methods like CalMap fail completely. As seen in these tables, the new fine-tuned models consistently outperformed existing state-of-the-art systems. These improvements were most noticeable in the hardest, most sparse test cases. On the screen, you can see how the new models create much more coherent 3D layouts compared to older versions. The visual comparisons show that the new approach captures global structure even with very challenging input images. In these real-world examples, you can see the system resolving ambiguities that usually confuse computers. Even when objects are repeating or the angles are uneven, the model discovers the correct large-scale layout. This shows the system is robust and confident even under severe data sparsity. Looking back at the data, this work signifies a major step toward creating a truly universal 3D foundation model. To recap, the core achievements are the MegaDepth-X dataset and the new training strategy for handling sparse data. These tools help AI overcome the lack of images and the confusion caused by symmetrical patterns. In the future, this could mean that almost any collection of vacation photos can be turned into a high-quality digital twin. This paves the way for better virtual reality experiences and more accurate digital mapping of the entire world. Thanks for watching Summarize Science, and stay tuned for more amazing tech breakdowns.